Welcome to part 2 of the truss analysis. So before we talked about can you determine if it's statically determinate using the equations, and then we use these words racks and ray and reactionary forces. So kind of summing those up again. Reaction forces are the forces of the ground or where it's attached to the earth itself reacting to something. So in this case, we have 500 pounds pushing down in the middle of the beams right here at this point. And it's pulling down because of gravity at 500 pounds. Now, there's got to stop, something's got to stop that from falling to the earth. And then what that is going to be these reaction forces are pushing up equally to the opposite of this. So 350 pounds plus 150 pounds equals that 500 pounds. So the bridge is neither going up nor down. Racks, on the other hand, the reactionary force at point A in the x direction has no other component. So that means that it's 0. So now we got racks, we got ray, we got the reactionary force at point C in the y direction, so RCY. Now that we got all of those, now what we can do is calculate the actual forces that the members are feeling. So, but before we can do that, we need to figure out our angles with inside. So we're going to use some basic trigonometry to figure out our angles on the inside. And then again, what we're going to do is assume all members are under tension, being pulled apart. And if it's a negative number, that just means they're being compressed. So we're just going to change that number. So all forces are going to be solved, and then what we're going to do is we're going to update free body diagrams using the correct magnitudes, senses, and subsequent joints. And so we can change it. So here again is a blown up version. And so what we're going to do is figure out all our angles. We need to figure out our angles here, 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 and here. So to figure out first, we're going to go to we're going to get our dimensions, and we're going to go to point A. So we got to get our A. So we know that the tangent is equal to opposite over adjacent. So opposite of this angle, 4 over 3. Take the inverse tangent of that, and we get 53.13 degrees. So now we're going to solve for angle 2 over here. We got 4 and 7. Again, opposite over adjacent. Fill it in. Inverse tangent of 4 over 7 gives us a 29.745 degree angle. So now we are going to update our angles. But because this is a 90 degree angle, a right triangle, we know this is 90, so we can solve for our other angles as well. Now what we're going to do is we're going to begin, and we're going to redraw our bridge, but this time we're only looking at the forces, not the members. So we're going to draw these arrows. These are the forces that the joint feels, not to be confused with the actual metal that itself. So we're not redrawing the metal, we're redrawing the forces, in which direction the forces feel. And again, we're always going to go inward unless it's a negative, then we're going to switch the arrows around. So we're going to fill in all our numbers that we know. So we know the reaction forces. We know our 0 here for racks, and we have our 500 down. Now we're going to go for the one that we know the most amount of information and solve for that. So this one, we know the most amount of information here. So we're going to solve for in the y direction. You can do it in the x, but y will actually be the easiest. So we know that ray, the reactionary force at point A in the y direction, has to be equal to the component, AB component in the y direction, downward. So this is where we have to break the AB into its components. So we do AB sine of 53. So this is the y component, this portion of our AB. So we then rearrange it, solve for AB, and we get negative 438. Now notice it's a negative number, so that means it's a compression, so we flip our arrow around. Now we got AB. So then we can change our overall drawing, and what's happening on A, B has to also be on BA. So now we have solved for that one. Now we're going to go to AD here. Notice that, again, we're going to do the exact same thing. AD, the x component of this, has to equal my AD. So now that we have AB, we can plug it in, negative 473.5 cosine 53 degrees, plus AD, this guy, so the x component right here has to equal this. We plug it in, solve for AD, and that gives us 262.5 pounds. And again, this is in tension because it's a positive number. Then we move over to point C, and we're going to do the exact same thing, moving over and solving for the y component of this point. Then solve for BC. Then we're going to solve for CD here in just a second. Again, redrawing as we see fit, solving for CD. Notice this is a lot of trig, a lot of algebra, so this is where it becomes difficult to keep track of what you're doing. So make sure you're writing down all your numbers. And then this one's the easiest one. Notice there's no left, no right. So BC or BD has to equal 500. And it's a positive because it's moving up. And again, it's in tension. And that's it. We've solved for all of the joints and members. Now, if this is too confusing and the math seemed a little difficult, please go review this again and again, slow it down, pause it, and rewatch it so that you can understand the algebra. This was kind of intensive in the algebra. So, again, if you have any questions, talk to your teacher.